All right, guys, so we know the answer to 1A. You take the absolute value. So, I mean, the ratio and root test, they both have absolute convergence built in. But anytime you take the absolute value of the given series and then test it, you're always going to end up with absolute convergence if it works, because you took the absolute value first. And then, what must be true to use this?
Oscillating, decreasing on the limit equals 0.
So not necessarily, well, yeah, okay, so those are what you need to be able to actually get that to tell you something. But what kind of function would it be? What does it have to have inside of it? Not oscillating. I understand what you mean by oscillating.
It has to be decreasing.
Negative, positive, that kind of oscillation. I like it. So it's got to have one of these kind of things inside of it, right? So do these go together? If I take the absolute value of something, what's going to happen to this piece of it?
It goes away.
It's going to go away. So then I would not be able to use that, would I? So could I ever use this? Could the alternating series test ever be used to show absolute convergence? Hell no. So be very careful. Some of us are still way optimistic. Absolute convergence should be even harder to show than normal convergence. So I couldn't just ever imagine that I could just say the limit is 0, ever, and be able to just go, it's convergent. In fact, alternating series is the closest we got. If the limit is 0, that looks good, but it still needs to do the other things. All right? So actually, there's one more main thing it's got to do, is decreasing.
So it can only be conditional.
Exactly. So alternating series, the most it could show, in general, is kind of like a conditional convergence, without taking the negative one piece away. The minute I take the negative one kind of piece away, it's not alternating anymore. Why would I ever consider to use a test named after that? All right, so that must become somehow related to something on the quiz. So yeah, what kind of convergence can it show? Conditional. Okay. Now this one, I know it's a little bit freaky. There's barely anything to do in part A. But still I had people... Yeah. So this is not 3n plus 3?
Yes.
What's inside?
3n plus 5.
Yeah, 3n plus 5. So now this would somehow lead to this. This looks like I maybe did a ratio test. And so after I simplified it, comes to here. Now how do I simplify this?
3n plus 5, 3n plus 4.
Yeah, the minute I have it written out like that, like a number, holy crap and a half. So 3n plus 5, 3n plus 4. How far do I have to go?
2.
Until I get that bottom one, because now the bottom one can cancel. So effectively the top would be what degree? What degree is the top half? Yeah, 1, 2, 3, 4. It'd be like end of the fourth. So somehow that's related to something on the quiz. And here, part C, I'm hoping some of you guys, well, let's see. What do you think about part C?
It's x squared, and all the rest have to stay inside of it.
The answer is what I circled. That's simplified. You can't do shit to that. The most you could do is maybe take an x out and have it x to the 1/5. I mean, that's not doing a damn thing for you. The big thing here is you cannot. So this is exactly related, and I know I do this a lot this semester, but that's just too damn bad. We know that if I say this, you ain't going to say this. And I don't think I've had anybody quite do that. But the fifth root of something is a plus b to the... And I still can't just distribute. Of course I can't distribute a power across addition, because powers are based on... What are powers based on? What operation are powers based on? Multiplication. So if I had ab to the 1/5, I could distribute that all freaking day long, because powers play well with multiplication, because they're based on multiplication. Powers do not play well with addition or subtraction, because they ain't based on those things. Coefficients play well with addition. I can distribute coefficients because they're based on addition and subtraction. Okay, good. There's a lot of analogous stuff in math like that. All right, what about part D? This one also had me worried. Yeah, so if you want to write it out for yourself, it'd be n to the second minus 7/9. So that's n to the 18 ninths minus 7 ninths, 11 ninths. Cool. And then you do whatever you need to for that. Okay. So if it was 1 over that, it'd be like a conversion P series or something. And number 3, there are quite a few people that just chose a BN that was just slightly different from the series you already had. But the series you already had, you didn't know what the hell it was going to do. So what do you want to know about the BN that you choose? You have to know. You have to exactly know if it converges or diverges. So you don't want to choose NQ plus N over the 4th root of N to the 11. What the hell? That is something I have to test. I want to choose something like 1 over N squared. Or 1 over N to the 11 ninths. Something like that. Right? And of course, how do I get it so that it makes sense with what I'm looking at? I do exactly this. The one time you're kind of allowed, and this is not even me simplifying something. If I had N cubed plus N over the, I don't know, Jeff, 10th root of N7 minus 2N squared, the way that I can get a feel for what BN should be, if I'm doing direct comparison or limit comparison, just to get a feel for what BN should be, and just get a feel for what the hell this thing does, is to look at the highest powers on the top and bottom. Just say these don't matter much compared to that. These don't matter much compared to that. So then I can do this. I'm allowed to do this because all I'm doing is getting an idea of what the BN is. And BN could be any damn thing I want it to be. Anything. But in order for it to work, it's got to be something intimately related to what you started with. So if I preserve the highest powers, and then this is exactly like that problem I had on the other side, right? This would be N cubed over N to the 7 tenths. So there'll be 3 minus 7 tenths, so forth, blah, blah, blah. Right? Of course, that bad boy is going to totally diverge, right? The bigger power's on top. It's never going to do anything good. Okay. All right, so let me finally give you back your quizzes. Yeah, the average was a 70. The standard deviation was 17. There were 5 A's, 7 B's, 10 C's, 8 D's, 9 F's. Here they go. Very good.
No, not there.
Dan. Justin.
I want it better.
Thank you. No, I did sign up for things there.
Sean? Eduardo? Elite. Mark? When?
Yeah, but I know
Cody.
Yeah, it just sucks. Like, I set up this one problem ever, and it's all
Toby. All right. Just take a few minutes, look that over, call me over if you have any questions.
Yeah, it's 4 down, but then you can go to 11, and that's like double digits.
I know, right? Pretty much everything is the stuff I feel like got wrong. Like as soon as I got home, I was beating myself up over all of these things.
Yeah, I want to punch myself in the face whenever you like know that you know how to do it. And you like,
Oh yeah, my biggest problem was the factorials. I did factorials wrong, and as soon as you do it in Word, I was like, damn it.
yeah, I did this one wrong. When I did on Word, where you just like take the square, you know what I'm saying?
Yeah.
I could not, like I'm sitting there, like I want to do it, you know, you said you're like,
Yeah.
whatever. I mean, at least you can like, you know, do the test and make it up, or, you know.
Can't even get past 0. So you have to buy all this. Then I would use.
Yeah, but yeah,
You've already done it when you write it. You've already taken the 0. So you did convergence. You have to also make the test for absolute. That's why I'm going to look at it and say if there's a chance it's absolutely convergent, I'm going to do that first. Because if it is, I don't have to do conditions. Does that make sense? So it's like do the two extremes. If I want to do the test for divergence, if that doesn't work, I do the test for absolute convergence. Unless it's really obvious what it's going to do. Yeah. Yeah, yours. The weird was, I mean, you don't have your limit, you didn't get your limit. So you can say it's right, show me what the limit is. And then say it's write the limit, that's number one. Write the limit in, and then actually do it. Tell me what it is. Yeah. Good. Yeah, and then go to
I used to not be able to do that. I was just
get there first. Show me what it is. Yeah, from the beginning that you see that it's part of the test. And then at that point, you would actually do the limit.
And then you look at the limits and what it is.
Infinity.
Yeah, exactly. It goes to infinity. It's bigger than 1.
Yeah, I don't.
Oh yeah, but it's not enough. Part of it within the decreasing thing never really got finished. Well, that was the other one. But yeah, you can't be rid of it. You wouldn't have to compare the derivative to the original. Show me that the derivative is always negative. Or is negative after something. Show me it's negative. Yeah. Show me the expression you get is always negative or negative after any 2. But for this problem, you should have to do negative. Look at the original.
So what is something like that, and then start finding out who's
Here's the degree higher. So it's a limited academic zero. No, so test for divergence, you're done. Yeah. This is what I'm talking about. You can't say that's not true.
Well, you just said,
No way.
No, that's right. There's no reason to care to say.
I look like I'm 5. Good.
And the ratio.
My brothers.
They didn't do a ratio test.
You were like this. Oh yeah, now you can cut down. I'm looking back up here.
I actually have no idea what they're talking about.
Oh, it's not true. That's so the result of the root test convergence is sort of like a middle, not as strong as I should be able to say.
My mom is not a box. And we had to listen to it all the way.
I saw the concert twice in a year.
That's only for you. I went out
I'm not gonna think it's just freaking absolutely.
I'm excited for Texas.
That works.
They're kind of
Oh, so when they're trying to try it, and they just want to use then you end up with this pedestrian over
What is it?
that I actually have.
It's the E to the 2 if I did it right. It's the E to the 2 and you put it in plus 1.
I told you.
You're gonna get 3 in plus 3. So, your end stuff should be the same as the delta's going on. Right here.
Words would be nice.
Let me do a problem like I'm just going to do this. All right, guys, I'm going to do a problem like, which one was that, George? The first one.
I got the right answer. I just don't know how to rewrite that bottom part.
To show you, one person did this. I want to say it well, correct. All right. So if I have, let me try to make a problem. It's sort of like what everybody has. Sure. Right. So everybody had something that looks sort of like that, right? Same kind of form. So to get a feel for what this thing does, I would just strip away some of this other excess stuff. Not even the 8 I worry about. So 13/5 minus 2, and the answer I can put on the bottom, 13/5 minus 2 is 13/5 minus 10/5. It's 3/5, right? So half of you guys had a first problem. This problem should diverge, and half of you had it converge. This particular one would do what?
Diverge.
Yeah, because P here is less than 1. It's supposed to be greater than 1 to converge. Good. So this series would diverge. So if I use it as Bn and the limit, the comparison test comes out between 0 and infinity, I know that this also diverges. And I'm pretty damn sure it's going to, because that's basically what that thing is trying to be. I don't know, I keep saying that, hopefully everyone understands what I mean by that. All this extra crap, if you take the extra crap away and just look at the most important parts, that's what it's trying to be. So when I set this up, the limit comparison, it'll be this guy in all his glory, not some simplified version of him, times, it would be divided by that, so times the reciprocal. Which doesn't look very promising. But let's see what happens.
8 to the 13.
Yeah, you get 8n to the 13/5
Oh, why don't you just
minus 2n to the 8/5. And the bottom is still the same. Let me stop there for a second.
So then can you just go straight to your 8?
Nope, now watch. To do this by the book. And the one time we have to still do this by the book really is when I have this big root in the way. Then I'm not as free to do the kind of touchy-feely thing we do when we say that look at the degrees. Because this is like a 5th root over this whole thing. And you can't distribute the root. You can't make it n 13/5 plus 6n 7/5 or something. Because the one big problem with that is how does 6 escape? But the bigger problem is you can't distribute that across a plus. Right? How are we doing so far? So what you do then is you do what you had to do way back when. You divide by the highest power. So if I divide by n to the 13/5, divide by, and of course what's n to the 13/5 as a root form? You can do it. What's the root? Yeah, because the roots are on the bottom of a plant, so on the bottom is a root. So the 5th root. And why do I want to write it like that? Because now I can actually get that thing in here. When can I divide something with a root? When I divide by something that has the same root. So on the top, I'm going to get 8, right? Divided by, right? The n to the 13/5 goes away. Minus 2 over n to the so we're dividing by this. 8/5 minus 13/5. -1, so it'll be 2 over n. Over the 5th root of, now I take the n13 inside, divided by it, so I get 1 plus 6 over what? Divided by 13 n's? Dividing by 13 n's, right? So what do I get here? So I'm dividing by, yeah. 6, where?
Down.
On the bottom, kick ass.
-6.
Of course, that's important because when I let n go to infinity now, what happens to this dude?
0.
0. What happens to this dude?
0.
0. So I do end up with, in this case, 8 over 1. And what's important about this?
That's between 0 and 50.
So when you do these tests, you have got to explain to me at the end what you're considering about that answer. Right? You understand what I mean? So I wonder, if you just say diverge, I don't know if you think it's because it's bigger than 1, which would be incorrect on this problem, right? What's the whole point of this problem? That should come between what?
0.
Beautiful. Just say real quick, this L is between 0 and infinity. Therefore what? Our series does the same thing that one does. Yeah. Ours diverges since Bn diverges. Coolness. So there's kind of two things going on. You can get a feel for something by doing all this illegal shit. It's really illegal, but it still preserves the main idea. So that's what this whole thing here was. Everything I did there was completely illegal. But that's really the heart of what that is. That's what's important. But then when you're trying to prove something to me, you better not do any damn thing that's illegal. Or else I could throw the whole damn thing out. Your argument is weak. Away. Okay, suddenly this is law class. That's all right. Okay. Sorry. Just want to show that problem. I knew that problem was a big one. Oh.
volunteered.
I'll check it out.
Where do you want me to stop?
Oh, good. Is it kind of looking at it? I got it focused on the overhead. All right, guys, let's slowly get back into. So put those quizzes away. You can finish those corrections. So again, a week from today is going to be the test. So let me go ahead and give you guys the practice test before I forget. And I'm thinking that I don't think anybody's got a problem with this. I think I'm going to push 11.9 to be on the next test also. So this will go up to 11.8. I didn't hear any reaction either direction, so. The sincere. So 1,000,000 sections instead of 2. Okay.
Well, Section 9 is Taylor series, right?
What's up?
Section 9 is Taylor series, 11.9 is Taylor series?
No, 11.10 is fine with Taylor.
Oh,
11.9 is like a little bit more with power, and kind of leading into Taylor.
Okay, good.
That's why I'm okay with pushing it back.
I want to start
Oh yeah, it's not absolutely when you did the alternating series. That's what you tell you conditional. Because for the alternating series, says you have to have the -1 in there. Absolute value would take it away, and you couldn't do the alternating series. Oh, here, Newsom.
Oh, sorry.
It's all right. Everybody back there's like, what's going on up there? It's like on a plane, you're waiting for food. You're like, where's that card at? Jeez.
I like your little.
Yeah, I got one.
Okay. So guys, do that. you're not sure how to do that, let me say it a different way. Do the, well, you tell me, what would you do on this to find the interval and radius? You would use the what? Ratio test. And the answer guy is built in there. So do the ratio test on this and see what happens. So let's see.
Yeah, it's got to be. I'm sorry. The n plus 1's always got to be first, so I go on top. Yeah. Just is that what you're winning?
Oh, I see what you're doing. So you're doing the same thing. You're trying to do the minus 1.
And that'll work. That's fine. Well, absolute values. And be careful there. Well, let's see. This should work. No, here. So be careful. You're trying to escape something. You're trying to escape the n plus 1 messiness. But if you do it this way, you're going to have n minus 1 messiness. You have to replace n with n minus 1. Period. Yeah. So either way you do it, you've got to write what that term before was.
It's changed so much. Yeah. It really is.
Is that cool? Just simplifying that. And what happens to the 2n plus 1, 2n plus 3? What happens to that ratio? Goes to 1 because they have the same degree. So this ratio goes to 1. what happens between these two? How many things cancel? 2n plus 1 things. So how many extra x's does this guy have? 2. Say it one more time.
The final answer would be x squared.
Yes, good. All right. Well, I don't have the limit anymore. I've done the limit. So this would be x squared, absolute value, which is really unnecessary. And of course, see we with that? See we got that much? And of course, I don't really need the absolute values anymore because x squared is positive, yeah. And of course, for this to exist, I have to, for the ratio test, to say it's absolutely convergent, this has got to be less than 1. So when is x squared less than 1? Negative 1 to 1. Right, take a square root, rewrite it as an absolute value. See the absolute value comes back eventually. So if you take a square root of both sides, you write this absolute value of x is less than 1. So negative 1 less than x less than 1. So so far so good. We're not quite done with this.
I thought if the n's go away, then all the values of x.
No. So if the x's go away, it's one of two extremes. Either it's going to be all values of x or no values. So just the one value, the a. In this problem, I know 0 works. And we call that, very often we call it the trivial solution. If I make x 0, then every term is 0. So the sum of that is convergent. Yeah, right, 0. So we call that the trivial answer. So that's why there's always going to be at least one answer, the boring answer. Okay. Okay. That's all I can say about it. So this expression, just to let you know, this is a little bit in our future. In fact, it's further ahead in our future now than it would have been. But if you're curious, page 762 has a huge table of these, and we're gonna prove after this test. We're gonna prove that this is a representation for the inverse tangent for x is close to 0. So if I wanted to know what the inverse tangent of 0.03 was, I could just plug a 0.03 into a few terms of this, and I could see where I have to stop to make it close enough for me. That's the idea. Do I have to understand any of what I just said yet? No. That's in our future. Just want to let you know that's where that came from. Yes?
Do you have to check the endpoint still?
Yeah, good. So I'm not quite done with this. How do I check the endpoints?
Plug them in.
Plug them in. Cool. So if I plug in -1, what do I get here?
Do you include the alternate?
Yeah, oh yeah. Because now I'm just looking directly at the series. So -1 to the end, that's in there. I'm going to plug a -1 in. This is going to get a little weird. Over 2n plus 1. So be real careful whenever we're plugging values in. This is for x, right? Our answer is always going to be in terms of x values. Don't plug them into n. You can get some really weird stuff happen there. So what happens on the top? What do you do when you have the same base? You have you multiply? Add the power, so you get -1 to the 3n plus 1. That's weird. Is everybody cool with that? You guys see that?
Which makes it even, so wouldn't all the values come out more?
Well, if you put a 2 in, what do you get? 7. Yeah. But it actually alternates. It's still alternating. It's just weird. You could rewrite this realizing that if I put a 1 in, it's even. 2 in, it's odd. 3 in, it's even. 4 in, it's odd. So it actually is still -1 to the n or n plus 1 or whatever. But let's see, what do I really have here? Is this absolutely convergent? This would be conditionally convergent, right? And how could I say that? How do I know that? Yeah, it's decreasing. The limit is 0. It's always easier to show alternating series are conditionally convergent. Would this be absolutely convergent? No. And what is that all about? Those are x values where this is absolutely convergent. Yeah. So no, it won't work. Right, you get like this divergent p-series. Hey guys. So you get like a divergent p-series that's not going to work. And what happens when you put a positive one in? Basically the same damn thing's going to happen, right? You're going to end up with negative 1, who cares, over 2n plus 1. So that's also going to not absolutely converge. So then this is the only thing that I can say there. You have to check those endpoints after you do that. And you are still checking for absolute convergence. Okay, maybe. Let's do another one. Just get one that's a little bit more interesting. So you're like, that was pretty damn interesting, dude. Let's see. Say again? Alright, so let's see what this looks like.
There's no
Okay. And what has to be true about the result for the ratio test to tell us? When you do the ratio test, your answer has to be your answer has to be how related to 1. Less than 1. Because it's like R, so geometric series. It's got to be less than 1.
So just force it to be less than 1. Solve for x. Yeah.
I just have one question. Could you use the root test?
Oh yeah, on this one you totally could. Yeah.
Oh.
Root test would work here too.
So you raise that.
We'll do it both ways. Sure.
That was the same thing I was.
I like it. So if you do it this way, what do you end up with here? You have one more of these here, so n of them cancel. And here you have an extra one down there, so you still have a 4 down there. Don't really need a limit anymore, it's all gone. And what's how to happen with this? In order for this to converge, absolutely?
It's got to be less.
It's gotta be less than 1? How do I solve that?
So x has to be between -1 and 7. You just make it 4 over 4.
Yeah, multiply the 4. What's up? So then -4 less than x minus 3 less than 4, right? That's how you do the absolute value inequality. Add 3 and you get to what you said, Jeremiah. -1 less than x less than 7. So far. What's up? You good? We still got to check the endpoints, but let me just do the ratio test real quick. I like that suggestion. It's a good idea. Everything's to an nth power. So if I do the ratio test, the root test. Yeah. Then what happens there? Yeah, these go away, so I get x minus 3 over 4 has got to be less than 1, and I get the exact same thing. I like it. What's the matter? Good. So when I was making this up, I was going to do it a different way at first, but if you notice all these nth powers, then yeah, sure, you can use the root test. Yeah, it's fine. You could use the root test or the ratio test. But if everything's got an nth power on it, sure, go ahead and do the root test. I love it that people are upset that it was easier. They do it that way, and they'd be happy to help. I can't believe it was easier. Well, it's easier to do it. So what do I still have to do, no matter which way we did it?
Endpoints.
Endpoints. So when I plug a -1 in, so if x is -1, what do I get here? Yeah, -4 to the nth over
So you get -1.
4 to the n.
It's no. No, because it has to be less than 1, not can be at 1.
No. We're not applying a test. We are seeing what would the series become if we put a -1 in for x. And then we're just going to look at the series. This is not a ratio test, root test. This is nothing. This is just what does the series itself look like. So you got to be a little careful with this. I got n -1s there, multiplies by each of those n -4s, and it makes it a positive 4. That's a quick way to do that. Another way to do it is to pull a -1 to the nth out, leaving 4 to the n, and then those two -1 to the nth powers cancel each other out. Because they're both negative at the same time. So either way you do it, you get this, which is obviously divergence, right? You add 1 forever, you're going to go infinity. So I can't include that endpoint. So this much is right. And when you plug a 7 in, you're basically going to get
Do the same thing.
same thing, except it's going to be positive 40 over 40. It's still going to get a 1. So in this case, it's not going to go to infinity, but it's just going to go -1 to 1, -1 to 1. And if you take the absolute value, then it's going to go to infinity. So either way, neither endpoint works. You end up with a sum of 1. But you have to check those endpoints. It's a random noise. All right, let's do one more. Let's do one that's a little freaky. This is kind of related to an earlier problem you guys had. So the bottom, is it a factorial? Does it multiply every single number down to 1? Or does it skip maybe like even numbers?
Even numbers.
So it's not a factorial. That's why they can't write it like that. They had to write it, they said just multiply all the odd numbers up to something. So the bottom is not a factorial, but it's going to be as easy as a factorial would be if you let it. A lot of stuff's going to cancel when you set up the ratio. Yep. Yep. Exactly. Cool. So it just kind of goes out one more term.
It's just like seeing. Yes.
Are you done here? Okay. If you told me you're ready, before you were fine. If you're doing your way, then it's always got to be yeah, you're right. You gotta think the bigger. So then this would cancel the term before this one would have been 2n minus 3. So see, this has got one more term on it, and then if you cancel, that's the one that's left. You see how it looks at that?
Yes, it does. Yeah. I mean, theoretically, math doesn't care if you go n plus 1 or n minus 1, as long as you put things in the right place. Math doesn't care. Yeah.
There is still an x plus times
All right, guys. So it's you guys see how this works? What would the first term be? What would the first term be? What happened? What's back?
Why'd you multiply the 2n minus 1 times?
All right, this is what I'm trying to explain right now. Because that's what it tells me to do, isn't it? This is exactly what it tells me to do. It says multiply from 1 up to 2n minus 1. That's what it tells me to do. So what would the first term be? If I let n equal 1, so what's a1? What's 1 factorial? What's x to the first? All right. And what's the bottom say? Multiply from 1 up to 2n minus 1. Well, if n is 1, what's 2n minus 1? 1. So multiply from 1 all the way up to 1. Okay. This is exactly the idea of factorial. It's just only doing odd numbers. Which, to be honest, somebody should have made a symbol up for. Maybe we'll create one. So what would A2 be? What's 2 factorial? 2x squared over. Yeah, you want to do 1 times all the way up to 2 times 2 minus 1. Well, 2 times 2 minus 1 is 3. So you want to do 1 times 3. And then the next bottom would be 1 times 3 times 5. And then 1 times 3 times 5 times 7. Right? This is what that tells me to do. Multiply all the way up to this. Which is kind of like, and sometimes it's very useful to write factorials the other way. So another way to write n factorial, watch this, it's kind of good for certain homework problems. Another way to write n factorial is 1 times 2 times 3 times n minus 1 times n. That is n factorial, is it not? Okay, cool. And if n were 1, I would get 1. If n were 2, I'd get 1 times 2. If n were 3, I'd get 1 times 2 times 3. That's exactly what we're doing here, except this is only working for odd numbers. Every time I get another higher n, I go further out in this product. That's what this says. Multiply 1 up to this. Okay, all right. So that's why I wrote this. Because this goes up to here, but then when I put an n plus 1 in, what do I get when I put an n plus 1 in? So now I want to go up to the 2n plus 1 term. How far apart are these? How far apart are 3 and 1? How far apart are this and this? 2. So there's still odd numbers, aren't there? Alright, so but now that we've gotten past that, and I wanted to do this problem specifically because you guys do have a couple like this, and you have one on the practice test, for example, which might mean you're going to have one on the test. 3C, for example, on the practice test. So what happens here?
All cancels out.
Yeah, all the way up to this dies. On the top, what happens with this guy? Yeah, n plus 1, because n factorials cancel. And of course here, I have one more x there, so if I cancel n of them, I have one x left there. So what do I have at the end here?
n plus 1 over 2n plus.
Yeah, n plus 1 x over 2n plus 1. Get out of there. 11. How are we doing so far?
That's what I got.
And then, of course, what's the limit of this? 1/2. Beautiful. So the limit of that is going to be 1/2 x, right? X over 2, 11. And of course, that has to be, we force that to be less than 1 and solve for x to see what values would allow this to absolutely converge. What values would let this be less than 1. That's what's going to make it converge. Remember that less than 1 is because it's like a geometric series. I think some of you guys are thinking it's like a p, you got to be greater than 1. No. Got to be less than 1 like geometric. So then x has got to be, absolute value of x has got to be less than 2. So you go -2 up to 2. Let me stop there for a second. We're not quite done yet, right?
Endpoints.
Endpoints a lot, so you gotta check the endpoints. So this is going to be a funky series. Let's see. If I let n equal to -2, what happens?
8 over 3 or something.
Yeah. Oh, I'm sorry. So here's a really good example of a problem where when you plug in the endpoint, do you see what this is trying to do? No. So I know for sure that the ratio test will not work here because that's what sent me here, is it says I don't know what happens at these endpoints. So I can't try to use ratio test on this somehow. You guys with me on that? Because I already crapped out on me. That's why I'm looking at this specifically. So what else can I do? Is there another test we can try to do? Is there... So I can't use the ratio test. That's what we've already used. And the root test won't help me out here because there's only one thing to an n power, right?
Correct.
Maybe. I mean, now let's see. This sucker has like everything and more than we're used to. It has factorial in it. It has exponential in it. And it's got this new little weird selective factorial in it. We should call it the selective factorial. Make a little exclamation mark with something on it.
Upside down.
I like that. Yeah, so that would be...
We should do that.
Looks like a really big imaginary number or something. It's weird.
Just do it on either side, like with
Slender Man.
like with the next one.
Right. Yeah. All these cool. Alright. You don't know Slender Man, it's probably better. It's probably a better thing. Alright, so let's do this. I can take out the negative one to back. I can actually probably just take it right out because I want to talk about absolute convergence here, right? What's interesting to me is that very often it's very obvious why the answer comes out to be like 1 to 7. So the last one we did was negative 1 to 7. When we plugged them in, we got something that canceled and it went to an extreme. If you guys remember from a few minutes ago. That last one we did, we got negative 1 to 7. When we plugged it in, you can see why those were critical points in a way. Because those came out to be 1 and negative 1, these extremes, right? So what's weird to me is it's not immediately obvious why 2 would be, or negative 2 would be an extreme. There's nothing else with it that really, it cancels or something.
It doesn't really hinder it, so we could add it.
Say again?
So it doesn't really hinder the series, so we could make it equal
Make it equal.
on the endpoint. I guess to...
Yeah, why is your 2 positive?
No.
No. I took the negative stuff out. So that's fine.
What I'm saying is that you can make it equal on the negative 2 is less than x.
No, we can't unless we know for sure that this thing converges. Absolutely. So one thing we could do, this is sort of like a problem in the homework, is to try to write out a few terms to see what's happening. Now, I want you to notice something. N factorial versus this guy. How do I say this? So this guy goes from 1 to 3, 5. N is going to go from 1 to 2 to 4. So the N factorial is always going to be kind of like lagging behind this dude. So when he's at 1 times 3 times 5, N factorial would be at 1 times 2 times 3. You guys see that?
Yeah.
Okay, so that's one. And what I'm doing right now is I'm just trying to get a feel for if this is going to converge or diverge. I'm starting to analyze my terms to see what's going to happen. So it looks like this and this are not on even terms. It looks like the bottom would overwhelm this, right? All right, so that's one thing to consider. That doesn't mean I can just cross these out and then that's going to go to infinity. I mean, the bottom overwhelms this piece. Does it also at the same time overwhelm this piece?
No.
Yeah.
Well, let's see. All right. This is where things get kind of neat. How do I do this? So let's analyze a couple of terms of this first. So let me just take that out. We're looking at the absolute convergence anyway. I don't want that getting in our way. So what would A1 be?
2 over 1.
So 2. I like it. A2. 2 factorial times 2 squared over 1 times 3. So it'll be 8 thirds, which is how related to 2? Bigger. Now this is not a proof. This is, again, anytime you look at specific elements, it's not a proof, but it's going to be really good evidence about what's going on. So what about A3?
6 times 2.
Yeah, so I'll get 3 factorial, which is 6, times 2 cubed
Over 1,000.
Yeah, 1 times g to the sine, so 15. So again, we see that this piece is always going to be smaller than that piece. That's what I was just talking about. You guys with me? That's the whole idea of the n factorial is always going to be like a few steps behind this guy. He's growing a lot faster because he's skipping all the even numbers.
But the 2 to the n.
But the 2 to the n piece is making that top grow pretty fast, right? Yes, sir.
I mean, pretty much unless it's a 1, couldn't you say that just about anything to the n overpowers a factorial? Anything greater than 1 to an n overpowers a factorial? Like if you have 2 to the n, 3 to the n, anything to the n, it should overpower a factorial. It should grow.
But you mean anything at least 2 maybe?
Yeah, exactly. If
Well,
two-
is that true? So like if you have 1.9 to the n. And again, this bottom is not a factorial, right? You with me?
right.
But according to what we found, if you have 1.9 in there, this actually converges. But exactly starting at 2, it looks like it might diverge. Because what do we get here? 48 over 15, which is now bigger than 3. So it was 2, and then bigger than 2, and then bigger than 3. And there's nothing there to make me suspect that that pattern is not going to continue. I don't know if you guys are with me. I mean, I know one reason I wanted to do this problem is because I didn't know exactly what was going to happen with it. I love that. And as a student, you sometimes don't understand this, but to me it's better to see the thought process that comes in instead of seeing, well, this is exactly how you do this problem. What's your problem? I mean, I'm trying to show you this is how I personally would analyze this thing. Because I looked at it, I was like, well, I don't know what the hell I think it's going to do. I want to see. So this is weird at the endpoints. I knew something weird was going to happen here. Yes, sir?
Can you kind of look at the denominator as kind of like n factorial plus 1?
No, not really. This is, that won't, I see what you're trying to do.
Your starting one wouldn't be 1 then, if it was like that. Oh yeah, you're right.
Yeah, it wouldn't do what you want it to do. There's no nice way to write this related to a factorial. There really isn't. But here's something we could do. You ready? And this will be the last thing I do. And then I'll try to finish this myself and bring it back next time. Because I really want to see. Now watch. If there was a way to fill this guy in, if I give this guy 2, 4, 6, won't he become a factorial?
Yeah.
But if I give that guy this, I better give that guy this, right? If I can fill him in, it might be easier to analyze this, possibly. I know I'm kind of moving the problem to the top then, in a way. Because then I'll have a bunch of just even numbers multiplied out, right? But I'm curious if that approach would work. So let me do this. Instead of trying to do it all up on the board, I'm going to try to write it out and bring it with me next time and just show you what I would try for this problem. And that's the next thing I would try, because that's our main problem is, if only this was related to a factorial, I could then compare these very easily. I could then do stuff with them, right? So maybe one thing is to try to fill this guy in. Or maybe there's something else I'm not even thinking about yet. All right. Well, that's plenty for today, I think. So everybody's got a practice test? All right. So 3C is a little bit like that one.
Hopefully not too much like that.
Yeah, I like it.
W